Hello everyone, welcome back to our channel. Now in this video we are going to implement an algorithm for heap, that is Heapify. So Heapify is an algorithm in heap in which what we do, we actually convert an array into a binary heap in place. Okay, so basically you have an array, okay, and you keep on doing the insertion in the heap, and you make sure that the elements that you're inserting in the heap, right, are forming the correct heap. That means it is performing those two properties properly. Every node has two children, and the value of the both of the children should be less than the root. So that's what we are going to do. We are going to take an array and we are going to convert it into a binary heap. So let's get into our implementation. We have an array. I'm going to print it as it is. We are going to perform the heapify operation, and then we are going to print it again. So as you can see, currently you don't have a heapify method, that's why it's in red. So let's implement this. For each of the element in this numbers array, right, which is numbers 2 dot length, let's name it numbers only. Okay, we are supposed to perform the heapify operation. Okay, let's create a overridden method which we are actually going to make use of recursion to implement this Heapify algorithm. Okay. And as the second argument we are supposed to pass the index. Okay, so it will take each of the index value whichever we are passing, and it will perform the Heapify algorithm. It will find the correct location for that particular index value, and that's it. Same thing we are going to perform for each of the number in the numbers array. Okay, so let's implement this heapify method. Yep, so we have a void method heapify integer number, and let's make this as index. Perfect. Now what do we need to do? First we are going to consider the largest index that we have is this index only. When we are trying to run this algorithm, right, first thing we assume is that the index that we are passing, right, is the largest index. So then we figure out, okay, let's check its left child index and right child. If any of them are greater, then we are supposed to perform the swap until the number at that particular index at its correct position. Okay, so let's do that. Let's first check if this index value is you know greater than its left child or not. Same thing we are going to check with the right child as well. So int left child index is equal to index multiplied by 2 plus 1. This is the same formula that we used earlier. Now we are supposed to check two conditions. If left child index is less than or equal to numbers dot length, number at the left child index is greater than the largest index, which is what we calculated earlier, and we have assumed that this index that we are passing is the largest index, right? And if the value of left child index is greater, then you're supposed to change the value of the largest index, which will have the value of left child index. Now same thing you're supposed to repeat for the right child index as well. Now let's write that logic as well. Right child index into 2 plus 2. If right child index is greater than number string, then largest index will have the value of right child index. So now till this point we know we have the largest index value. Okay, now we are supposed to check if index is equal to largest index, then you're supposed to return there itself. That means both of these conditions were false, and the index that you're passing, there is no change in that. That means if both of them are equal, you're supposed to return the control there itself. If this is not the situation, right, then you're supposed to perform the swap operation where you will pass the array, okay, you pass the index and you pass the largest index. And once you're done with that, you're supposed to once you're done swapping those elements, right, you're supposed to perform the Heapify algorithm again, numbers, and you're supposed to pass the largest index this time. Now this Heapify method will keep on running in the recursive approach, and it will keep on running till it is able to find its correct location. For what correct location? The index that you're passing right now, right? For that particular index, it is supposed to find the number at that particular index is at the correct position in the heap or not. Now that is what you are trying to achieve, right? You're trying to convert the array into a heap. So until it gets into a correct position, this will keep on running. Okay, and once it's at correct position, you will return the control, and that's it. You will keep on doing this for the all the numbers in the array, and finally you will have a binary heap with you. Now this looks fine, the logic and all is good, but this logic can be optimized in two ways. Okay, now the first optimization would be the so as you can see, we are running till numbers dot length, right? So if you actually have the structure of the binary heap, right, you will understand the iteration that you're performing. For every single parent, they are supposed to be at its correct position, right? So for the last level, they are the leaf nodes, all of them are children, right? So you can actually ignore iterating through the last level, that is leaf level. Okay, now, how do you skip that? Mathematically, even if you're checking, right, this is what the logic that you're going to get, divided by 2 minus 1. So if you divide the number of length divided by 2 and you subtract 1 in that, right, then you can ignore iterating through the last level, through all the leaf nodes, and you will save a lot of time in the Heapify algorithm. Now that was the first optimization. Okay, now the second optimization that you can do, the iteration that you're doing, right, actually you can iterate this in a reverse manner. So when you're iterating in a reverse manner, so a lot of nodes which are in your binary heap, right, so they will be already at its correct position. So while iterating, you will actually skip a lot of operations through which, a lot of calls of Heapify will be saved. You don't have to make those calls, and that can happen if you're running this loop in a reverse manner. That means if I is equal to this and I is greater or equal to 0, and this will be I minus minus. And let's see if you are able to convert this array into a binary heap or not. That means first we will print the numbers as usual, and if you are able to convert them properly in the binary heap, right, so we should see them in a decreasing order in this array. Let's run this first. Now look at the method. I have also made one more change, which is changing this. Now when you copy paste, you forgot to rename few variables. So it was earlier left child index, I have made it right child index. Now when I'm trying to run this Heapify algorithm, this was the error that we passed. As you can see, this is the error that we passed, right? Now 8 is the largest in the array, so that's why after the Heapify algorithm, we are getting 8 as the top root node, which is correct. This will be our top root node, this will be the left child, this will be the right child. 3 and 1 will be the left and right child of 4. 2 will be the left child of 5. So our Heapify algorithm is working perfectly fine. Okay. Now this was the logic for the Heapify algorithm to convert an array into a binary heap. Okay. So that's what I wanted to explain as part of this video. See you in the next one in something interesting. Bye bye.